All right, started to record. So, to B, and I'm looking at number 14. All right. So, a doctor administers a drug to a 23 kilogram patient. So, 23 kilogram. All right, using a dosage formula of 56 milligrams per kilograms per day. Assume that the drug is available in a 400 milligram per 5 milliliter suspension. So we'll have to sort out what these numbers are telling us. So 400 milligrams per 5 milliliter suspension, or in 500 milligram tablets. So we're going to have two questions here. So question A, how many one second. Okay. How many tablets should a 23 kilogram patient take every 4 hours? That's the first question. Three kilogram patient take every 4 hours. And then the second question, which we'll deal with here in a second, but reading it, has a drop factor of 10 GTT per milliliter, delivers the drug intravenously to the patient over a 12-hour period. What flow rate should be used in units of GTT HR? All right. So, so to solve problems, and we're doing the unit analysis, we want to first identify the units being involved in the problem and the units that you expect for the answer. The problem asks how many tablets a patient needs to take every 4 hours. The units involved in the problem and the units you expect for the final answer are, you've got the patient mass, which is 23 kilograms. You've got your dosage formula, which is this right here, the milligrams per kilograms per day. Your tablet dosage, which was 500 milligrams per tablet. And the units expected is going to be tablets per 4 hours. So number of tablets for 4 hours. All right, so let's see what we get. So we're going to set up, as we were last week on Wednesday, setting up a chain of these units. Now, what makes this problem, I think, a little more difficult is you're using units you're not accustomed to, and we're working in an applied situation that we're not used to as well. This is in healthcare. And but what we're going to try to see is, in terms of how I set things up and how units cancel out, it works just the same as any problem we had looked at previously. All right, so we'll start with our patient. And so as I put the thing together here, and remember what we're trying to get to is tablets per 4 hours. So make sure we write down our units in our chain of conversions here. All right, so 23 kilogram, that was our patient mass. All right. Now, going back and looking, remember what was our dosage formula was right here, and it was 56 milligrams per kilogram per day. So put that in there. So this is multiplication. 56 milligrams per kilogram. So notice these kilograms are going to cancel out already as I multiply those together. And then we also had per day. So I'm going to write that in. It's just 1 over unit of day. All right. Now, so then I'm going to look at getting that day to cancel out. So that is 1 day. Those would cancel. Now this was, we're looking for 4 hours. So if I think about 4 hours, and there's 24 hours in a day, 4 over 24 is 1/6, or 4 hours is 1/6 of a day. So 6 here, and we're going to put right here just for reference this 1/6. And I wrote days, and I meant hours. So it's per 4 hours. Okay. Can't spell. Okay. And then 1 tablet per 500 milligrams. Okay. Now remember, what I'm wanting to get to is tablet per 4 hours. Now let's look and see about units canceling out. Getting everything to cancel out the way we want it to. The kilograms are going to cancel. Day cancels. Milligrams cancel. And what I'm left with as I go across the top in terms of units is tablet per 4 hours. All right, so at that point, it's a matter of then multiplying 23 times 56, and then we're going to divide that by, in the bottom, 6 times 500. So I'm going to kind of write this in terms of the numbers. 23 times 56, and then it's just times 1 across. And in the bottom, I've got 6. 6 times 500. Okay. So punching that up on our calculator. Now, the units again that we're left with is tablet per 4 hours. And so that comes out to hundreds place. And I want to go ahead and punch that on my calculator real quick. About 0.43. But if I go 23 56 divided by 6 divided by 100, and rounding to hundreds place, about 0.43, a little less than half a tablet every 4 hours. And that is it. That is our, I didn't put the line there. Just trying to circle the answer here. Okay. So, recapping on this one again, putting in our known values, um, starting with the patient's mass, then times dosage rate, the formula you use, then times the desired amount of time, which was every 4 hours, and then the tablet dosage here. And again, the important thing here is to see how kilograms over kilograms, milligrams over milligrams, and again, the days cancel out here, leaving me with that tablet per 4 hours. And then it's just a matter of crunching the numbers. All right, so that is definitely a tougher one. And again, I think so, because of the fact we're using units we don't normally use in an applied situation we don't normally or have any real experience working in. I don't myself, but important thing is to see how everything mathematically still works the same. All right, any questions here on part A?
Not for me, thank you.
Okay. All right, so that's the first part of the question. Now, I'm going to turn the page. And now we're looking at, again, still number 14 and part B. And now we're thinking about an IV. We got a suspension, has a drop factor. So as it, if you've ever seen an IV and it's hooked up, it's got the bag here and then little gizmo, and then you see drips. It's dripping out into the tubing, which is then fed, into the IV. And so there's a drop rate and how fast it's being administered. So this is measured with rate of 10 GTT per milliliter. And it is delivered over a 12-hour period. Okay. So, question: what flow rate should be used in units of GTT per hour. Okay. So, in terms of units again that we're dealing with, our patient mass, which we know was 23 kilograms. We got our dosage formula, which was the 56 milligrams per kilograms per day. The suspension dosage, which is milligrams per milliliter. The drop factor, and then the units expected, again, that we're wanting to get this GTT per hour. All right, so setting up, again, chain of conversions, and then observing how the units cancel. We'll start with our 23 kilograms, our patient's mass, times our dosage formula, which was the 56 milligrams per kilograms or per day. Now, we're wanting to get to here over what, 12 hours, I believe was the over a 12-hour period. Now, I'm going to need to get this day to cancel out again as before, but I'm going to do 1 day, which is 24 hours, then times 5 milliliters per 400 milligrams. Now, and that came through the bag of medicine. It's got the fluid in it. It is 400 milligrams of the drug per a 5 milliliter suspension. So saline solution or something like that. So five milliliters per that 400 milligrams. And I arrange them this way, incidentally, because we're talking about equivalent top and bottom, but I arrange them this way so that my milligrams are going to cancel out here and here. And then our last part of this, the drop factor. That is how the rate at which it is the drips are coming out. And that was the 10 GTT per milliliter. Now, just looking to see our milliliters, our milligrams day. And what am I left with? And what am I trying to get to? The GTT per hour. Okay, also the kilograms. But that is what I'm left with, GTT per hour. All right, so now as before, so I'm down to the units I need, GTT per hour, but I would 23 times 56 times 5 times 10. That's all in the top. In the bottom, I'm going to divide this by the product of 24 times 400. All right. And that's going to come out to, rounding the hundreds place again, 6.71 GTT per So definitely one of the tougher problems for sure. Any questions on that?
You always round, like when you're taking a test or a quiz, it says round to the 100th decimal or the whatever decimal.
Yeah,
That
so
really screwed me this quiz.
yeah, so when you're working either a homework problem or a quiz problem or a test problem, um, look in where the answer field is.
Yeah.
There's always a little thing in blue, uh, which tells you how to put the answer in. And so if the number is a decimal, it will say, round to tens place or round to hundreds place. And so in looking at this one, for this particular problem, it says type an integer or decimal, when both our answers were in decimal form, round to the nearest hundredth as needed. So, meaning, sometimes you may say round to the nearest hundred as needed. So where that as needed part is, perhaps it terminates right after tens place. So obviously you're not going to have that second decimal value.
Right.
In that case. But yeah, so you always pay attention to that blue. It will tell you where to round.
Okay, thank you.
Yes, you're welcome. All right. Any other questions? All right. So let's go ahead. Questions and look at still in 2B. The last problem, number 15. So we'll get out of the medical world, and looks like we're going to be dealing with hot tubs and electricity. So in this particular problem, we've got an outdoor hot tub, and it draws 1,530 watts to keep the water warm. Now, if the utility company charges 16 cents per kilowatt hour, how much does it cost to operate the spa for 4 months during the winter, 24 hours a day? Assuming each month has 30 days, we'll round off to. All right. So, so we know we want to get to a cost. So I'm just going to kind of, oops. Hold on 1 second. I lost my whiteboard. There we go. All right. So, let's see. The hot tub draws 1,530 watts All right. It draws that much to keep it running, keep the water hot. All right. Utility company charges UC charges it charges what? 16 cents. So put that zero, it's not significant, so we're 16 cents. 16 cents per kilowatt hour. So 16 cents per kilowatt hour. Now, we want to know how much it's going to cost to operate this thing. So how much we're going to get charged for electricity. And so let's see here. So we got to figure out, first off, how much power we're going to use in kilowatt hours total. We know that we're going to be 16 cents per kilowatt hour. So I need to figure out how many kilowatt hours I'm going to use, and then I can multiply that by my 0.16. So let's see. So I need a conversion chain here that is going to leave me with kilowatt hours. So let's see what we got. We've got our 1530 watts. And then I've got, and this is metric right here, because we're going to need to get the watt to cancel out. So and we need to get up in the top kilowatt hours. So what's equivalent to watt in metric? Kilowatts. 1 kilowatt. Or in 1 kilowatt, that is 3 decimal places. So it is 1,000 watts. These are equivalent, but that gets my watts to cancel out, and it gets me my kilowatt up top. Now, I know this is going to be over what, 4 months. Now, to get months to cancel out, we are told to assume that there will be 30 days in what, 1 month. So I can get my months to cancel out. Now, I need to get hours up top, and there are 24 hours in 1 day. That gets my days to cancel. So I'm looking, I got my watts to cancel. I've got months to cancel out, and I got days to cancel out. So up top, that's where you get the kilowatt dash hour. Now it's just a matter of crunching the numbers. 1530 times 4 times 30 times 24, and then the product of those 4 numbers divided by 1,000. And that's going to give me hundreds place 4,406.40 kilowatts, not significant on the 0 there, kilowatt hour. All right, so that's how much power, kilowatt hours, we are going to use. All right, now to get our amount of money, is again, it's just a matter of multiplying this by 16 cents, but watch how the units work. I'm able to take this 4,406.4 kilowatt hour times the amount that the utility company charges, which is 0.16 of a dollar. That's what costs 16 cents. 0.16 of a dollar per kilowatt hour. All right. So those cancel, leaving me just with the units of dollars. And that comes out to this times this. I'm going to punch the numbers on that real quick. 4406. Six. All right. And you're going to round this to the nearest whole number. So that's where I use the squigglies because we're approximating. They don't look like squigglies. But it rounds up. The actual answer there is 705.024. We're going to round that up to about, it's going to cost you about $705. So, so if you run your hot tub all winter, 24 hours a day, keep it heated all the time, it's going to cost you $705 to do that. Any questions on that one?
No, thank you.
All right. Any other questions out of 2B? Going once, going twice. Well, let's.
Hey, Chris, I've got one.
Yes,
When
sir.
you put this video will also be up so I can go back over it, or we can go back over it again, correct?
Yes, sir. I will. So basically, after every class session, within the an hour or so past, when we're finished, I upload it and send the link.
Okay, thank you.
Okay. Now, all right. Let me get in here and look. Okay, so we have chapter 1, chapter 2 test. That is, we have everything done, chapter 1, chapter 2. We've taken a quiz for chapter 1 and we've taken the quiz for chapter 2 that has been assigned everything but the test. My intention today was to cover 3A, which deals with percentages. But in looking at where we are as a class, there honestly at this point today, about half of us are just a little bit behind, and the other half are a good bit behind where I would like to be. But I always said, well, we're not really, we're not driving. We don't have to slow this thing down a little bit from time to time. So I'm making an executive decision that I'm not going to go into 3A today. But I am assigning the test, and it will be due. I got a due date of the 30th, which is Wednesday. So I've already got that due date assigned. I need to look at one other thing on this. Now, so basically, here is the deal. I need you guys to really get in there and get yourselves caught up. This opportunity with me not moving on to new material. I was hoping we'll be a little bit more done by today than where we're at, but it is what it is. So use this opportunity between now and Wednesday. Get yourself caught up and hopefully able to take the test that I'm going to assign. In fact, I'm going to do it right now, lest I forget. Oops. I need to change that due date. Okay, got the due date signed. And now it is assigned. So work as hard as you can today, tomorrow, and prior to class on Wednesday to get all outstanding homework quizzes taken, worked through, and the tests. Now, quizzes can be taken an unlimited number of times. Homework can be, problems can be done an unlimited number of times. Tests can only be taken twice. You have basically two shots at it. So my hope is that everyone will have taken the test at least once. And that way, if you want to get with me about questions of problems you missed prior to taking it the second time, you'll have that opportunity to do that. Because again, like anything else, all of the assignments, you can work past the due date. So is everyone clear on our game plan between now and Wednesday?
Yes.
Okay, so
Yes, I am.
that is your charge, is work as hard as you can between now and Wednesday, with the goal being to be caught up and have taken the test at least once. So, if we fall a little short of that goal, we're still in a better place than we are right now. So again, work as hard as you can. So again, I'm going to not go into the next section, 3A, which deals with percentages. In dealing, that is definitely an everyday turn on the news. You hear percent. You can't go through a day without hearing a percentage somewhere about something. And we're going to do a real thorough investigation of the use of percentages. And I look at it as a way, really, when you really understand, if somebody's trying to pull the wool over your eyes, or trying to skew things a little bit, you're going to pick up on it. You're going to, no, that's not quite right. So, but that's where we're headed, percentages, and what we will do definitely on Wednesday. So, what I will say now is, it is 11:41. I'm more than happy to stick around and answer any other questions about problems you may have. Otherwise, you are free to go. And so I will leave it at that. Get out of here, and but I will stick around if there are other questions. So otherwise, I will see you on Wednesday, unless you're in 120E, and then we will be back at 1 o'clock. So
Thank you.
thank you.
Hey, Chris, if I have some questions, I'm still, of course, getting caught up. If I send you an email or such, I'm supposed to meet again with Anthony on Wednesday. So I'm gonna keep chugging along at it, but I appreciate the little bit of respite for right now, so I can try to get caught up. And then if nothing else, then I'll see you at 1 o'clock. But I'm out at the college again today. So are you planning on coming out this week anytime before?
I don't have any specific plans, no. I can if needed.
Oh, no. I was just asking if you were. I would make specific plans to try to be out here. But if you're not, I'll come when I can. And then get with Anthony and such. All right. I'll see you at 1 o'clock then.
All right. Sounds good.
Right.
Thank you.
Thank you.